Hello everyone, welcome back to the channel. Today we are going to discuss Azure Service Bus. You might have heard about the messaging patterns such as Enterprise Service Bus, First in First Out services, and other messaging patterns. Microsoft Azure offers the messaging service which they call Azure Service Bus. Let's first of all understand the need of Service Bus. So in the asynchronous processing model, you often found a requirement wherein the request requires to be processed asynchronously based on the variety of load, such as your system is scalable and it can have the variety of load. For example, on a specific time period the load might be low, but on the given time period the load might differ and it can go to higher and higher. So to simulate that kind of a load, or to serve those loaded requests, you need a asynchronous programming model. That's where your service bus architecture comes into the picture, and which helps you to create an architecture which is feasible for performing the asynchronous processing operations. Let's look at the Service Bus definition. Microsoft Service Bus, as I mentioned, it is a multi-tenant cloud messaging service which you can use to send information between the application and services. By that means that I can send the message from sender to the service bus, and which can be received at the receiver location. In the service bus, we have the brokered messaging pattern wherein a sender sends a message and it will be received by the receiver location. So receiver will receive the messages which is whatever it is been sent by the sender. And we also have the publisher subscriber mechanism wherein a sender can publish a message to the service bus on the service bus topic, and then a service bus topic will have multiple subscribers, and the listener or the receiver will be listening to the different subscriber, and when the message condition within the subscriber matches, the receiver will receive the message and will act on it. As you can see here in this particular diagram, sender is sending message to the topic. Within the topic you have the multiple subscription, so same message is being distributed amongst these different subscriptions, and within the subscription there are multiple listeners or the receivers which are listening to the subscriber. So whenever a message arrives into the subscriber, a receiver check for the condition defined in the subscription, and then once the condition matches, the receiver reads the message and then act on it. Let's look at the demonstration in Azure. How do you provision the service bus in Azure, and how do you send and receive the messages into the Azure? So I'll log on to my developer portal. Let's create and add a new service bus. To add a new service bus, you need to search with the services called service bus and create a new service bus. It is a publicly available service which is a platform as a service, so the name of your service must be unique. So I'll call it Azure Service Bus and then demo. Let's see if it is unique. Yeah, as you can see, this is unique, and I'm going to choose the location. So nearest possible location for this demonstration for my subscription is West Europe, so I'm going to leave it as is. Here you have the multiple pricing tier available for your service bus. So basically, if you choose the basic pricing tiers, then you will get the messaging option only, but if you choose standard and premium, then you will get an option to send the message standard message, which is the brokered messages, as well as you can use the topics. In this demonstration we are going to choose the standard subscription, so I'm going to choose the standard pricing tier and then review, create a review. It's going to validate and create the size bus. Might take a minute or I'll just pause the video, and now you can see the service bus has been created. So I'll click on the service bus, and here you can see the details about my services, when it is created, which resource group it is part of, what is the location, and all of the details are given. Here in the settings section you have the Service Bus shared access policies. Which is the default access policy for your Service Bus. So any entities which you create within the Service Bus, that particular Service Bus using this access policy or the primary key or Service Bus connection key, you should be able to connect to the Service Bus. Well, check the connectivity and the security section of your Service Bus later in the demo. Next is the entities. As we have selected the standard tier, so you have got the option of both queues and the topics entities. So let's create the entity called demo. So the name of my queue which I'm going to create is the demo, and once you have the enter the name, you got the maximum size option, max delivery count, and the time to leave the messages, and all the other settings which we will look at in the details what these settings are and how do you use these different settings for your implementations. So don't worry about this, we'll discuss it in very detail. So let me create a service queue for this demonstration. So I have the service bus created. Now let me go ahead and copy the shared access policies or the connection string of this service queue so that I can connect the application or the service bus messages or the queue from my application code. So I have created the application code on my Visual Code. So I have a Visual Studio Code which has the demonstration for sending and receiving the message. So here in my Visual Studio, I have created two console application. One is sender, one is receiver, and in the sender console class in the program.cs, I have declared the service bus connection string. So I've already copied the connection string values here and then the name of the queue which I've created. Here in this section, what we are doing, we are declaring the queue client, iQueue client from the namespace microsoft.azure.servicebus. This is the NuGet package which I've used in my console application. And with the help of iQueue client, I'm creating the service bus queue client object, which requires the connection string of the service bus, which I'm passing it here, and the name of the queue. Once it has both the information, it will create the queue client and uses the queue client to send the messages. So here in this case, I have the send simple message async method. This is a simple message which accepts the integer value, which defines the number of messages which we need to send. And here in this method, what I'm doing is I'm calling the getOrder method. This getOrder method basically prepares the different orders for the pizzas. So I have the pizza class defined here. It is just a simple class. In this class, we just got three property for the customer name and the size of the pizza and the type of pizza. So if you can see here I have created two lists. One is the customer list and the pizza type list. So what we are going to do here is we are creating the list of pizza orders for each of the customer. So I'm running two loops. One is for the customer name, and then for each customer I'm ordering the number of available pizzas types. So by the end of running this method, I will have totally 3 into 3, which is 9 pizza orders for the order collection. So once the order collection is ready, I'm running again here a for loop for each of my order. I'm serializing the object, the pizza order object, and then creating the object as a message type, and then I'm sending the order here with the queue client message. I'm using the send asynchronous method. Here in the message class or the message class for creating the order, we are using some of the message properties which is called label. And label here we are defined, okay, label type is pizza order, and the content type of the type of content which we are defining for this message is the application/json. So if I'm going to run this application now, it started sending the messages, and total 9 messages it has sent. On my receiver demo, I'm receiving the messages which I've sent on my sender demo. I'll run .NET run command, and this should receive the messages. We have the similar code in the receiver. It's just we are using the receiver client instead of the sender client, and you can see that I've got all the messages. For this demonstration, basically I run uh, the sender message twice. That's why you got the 18 messages. So it has read all the 18 messages, and you can see that the queue has got no messages left. Let's look at some of the common uh, best practices or the best feature of the Microsoft Azure Service Bus. We'll go through the each and every feature. We'll pick up some of the best features available in Microsoft Azure Service Bus, and we'll discuss what those features are and how you can leverage those features in your implementation or in your application architecture. So let's first of all discuss about the peak log. Basically, when you receive the messages at the receiver end, you have got two options to receive the messages. One is the peak log and other one is the receive and delete. When you use the peak log, what we are saying here is you send the messages, message goes to the queue, and then at the time of the peak log, basically receiver receives the messages, and once it is received, the message gets locked on those messages. So within the queue, there will be lock applied on those messages. Meanwhile, the receiver is processing those messages. So basically, the message will not be deleted from the queue. Meanwhile, it is processing. So in case of anything goes wrong, the receiver needs to drop out the messages or to abandon the messages. Basically, in case of once the receiver abandon the message, it will release the lock, and then the message will be available to the subsequent receiver or to the same receiver next time. So by using the peak log, basically we are not deleting the messages. We are asking receiver to we are asking queue to log the message for the time being when the receiver is processing on that. And if receiver abandon the message, then the lock will be releases and it will be available to the next processor. So here is the sample code which you can use to peak lock your messages. So, as we have seen in our previous demonstration, we were creating the queue client object. So here in the queue client object, when you create a queue client, you can say, okay, at the subscription or the queue client normal queue publisher subscription or normal queue client, you can say that, okay, in case of receiving the messages at the receive client, I want to apply the peak lock on my service bus messages. Once message received successfully and processed, you'll call the complete async method to complete the message processing. Next method is to receive the messages, the receive log. And the receive log, basically sender sends a message to the service bus. Message is received at the receiver end, and now it is receiver's responsibility to act on that particular message and to process the message. And if anything goes wrong with that particular message, the message will be lost from the queue. So queue itself will not have any responsibility to handle the message life cycle or to maintain the message life cycle. Yes, you have the option for, let's say, uh, dead, dead letter is specifying the dead letter of within the message, but whenever the message is going to be read, or let's say it's not completed due to some reason, then the dead letter count will be increased, and after applying the after reaching the dead letter count, it will be sent to the dead letter queue, or it will be erased from that particular queue. So let's look at how this receiver log works. Sender sends a message to the receiver log, and then it is processed by the receiver. In this case, receiver will make sure that it is processing in the way they want to process the message. Here is the receive and delete log. How do you apply receive and delete log? So here in this section, as you can see, you apply receive and delete log while creating the message receiver object, class object. Now the question can be asked that which one is the best suitable approach for receiving the message. Is it a pre-clock or the message receive and delete option? So Microsoft's suggestion here in this case is always go ahead and use the pre-clock, because when you use the .NET libraries for handling the message receiver or receiving or using the .NET library for the message receiver, and then it gives you ability to automatically append the message, automatically you know put the messages back into the queue. So it is always recommended to use the p clock. Now if that is the case, then why do we need the receiver and delete clock? So there could be a scenario wherein you have a requirement of high volume throughput for your service bus message processing, but you don't care or the less concerned about processing or the life cycle of your messages. Then it might be possible that the receive and delete is the suitable option for your implementation. So it depends which option you choose, but if you maintain the life cycle of the messages, then that's the recommended way. Let's look at the next option now, which is third one, is the deferred messaging. Deferred messaging, basically what we are saying is sends a message to the service bus queue, receiver receives the messages, and due to some reason, let's say receiver has got the message, but now to process the message, let's say receiver needs some database record or some data entry to be available in the database, or some other data storage option which is not available, and due to the other data is not available, receiver is not able to process the message at that particular point of time. So what default message option gives the receiver as an option, that receiver can say that, okay, I don't want to process your messages, or I'm not able to process this message at this point of time. So what we can do here is, you can go ahead and park this message for time being, and after certain period of time I'll go ahead and pick up the message again. Once the data is available to me, I will go ahead and pick up the data, this active message again, and I will try and play the or act on this particular message. So let's look at the representation here in this section right now. Message goes to the queue, receiver receives the messages, but due to some reason receiver is not able to process the message. So what in this case, how receiver will determine that I'm deferring the message, and I'm basically deferring the message, and now I need the same exact message to reprocess after some period of time. So basically in this case, receiver will use the sequence number property of the message. Yeah. So whenever receiver is going to defer a message, it will you know defer the message will come back here, and the sequence number, based on the sequence number, message is deferring is going to work. So now the question can be asked by someone, that what happened, let's say message has been deferred by receiver, and after some period of time it might possible that the receiver itself is down due to some reason, and to uplift the receiver, it might take some time, let's say 5 minutes. For 5 minutes of duration, the receiver is down, and now as you deferred the message, obviously no other receiver can receive, only the same receiver can be received, and based on the sequence number. So obviously once the receiver is up and running, if after uh, backing up the receiver, if the receiver still has got the sequence number available with them, then the receiver has got the option to receive the same number based on the sequence number, same message based on the sequence number. If a receiver is down and it has lost the sequence number as well, then you do not have any option to retrieve that particular message back again. In that case, the message will not be destroyed from the queue, but it will be lost in the queue, and it will not be received by any other receiver uh, for the processing. So this is how you need to design. If you really want to leverage the deferred messaging scenario, then what you should do is you should make sure that your workflow is storing the sequence number just before the deferring the message. Your workflow is basically storing the message sequence into, let's say, some sort of storage, let's say in the database. And once you try to receive the message again based on the sequence number, you make sure that you are using the same sequence for receiving the message, something like that. Yeah. So here is the sample code for deferred message, and you can see that here in this sample code, what we are doing here is we are deferring the message based on the sequence number, and we are adding the deferred sequences into some sort of storage collections for the future use. And here, when you retrieve the message, we use the sequence number to retrieve the message from the queue, and you use the receiver dot receive deferred message async method for that use. I hope that makes sense. Let's look at some of the other options. So next we have got the rule filters and actions. So in the service bus queues and the topics, basically you got different filtration options. So filter option are false filter, SQL filter, true filter, and the correlation filter. So what is false filter? False filter specifies that whenever a condition is going to be false, this the message will be uh, applicable to receive at the subscription level. Okay, so you have got, let's say you got the topic, you got the different subscriber and the different receiver listening to the subscriber. So on your subscriber, on your the subscription, you can specify the filter condition, and based on the filter condition your message will be filtered through the different receiver location. So here, if you look at the screenshot of the ARM template, here in this ARM template, what we are saying here is on the resource, which is on a particular topic, which is the name of the topic, for example, we are saying that create a rule on the subscription within the topic, the name of the subscription, and this filter type is SQL, and the filter condition is, let's say, within the SQL server you have a table, or the in your message you might have the property called the store name, and if the store name is equal to 1 and required processing equal to false. Okay, so what we are saying, if the store number is equal to 1, then don't process the message, otherwise process the message, something like that. Okay, so this is one of the example. Another one could be let's say messaging filter based on the multiple conditions, wherein you are saying, okay, SQL filter condition is based on when the color is blue and the quantity is 10, then your subscription should receive the messages from the topic, and it will send the message back to the receiver for the processing. Yeah, so that's how you can use the rules and filters and actions within the publisher subscriber mechanism within the topic and subscriptions. Now next look at the we are going to look at the auto forwarding of the messages, how the auto forwarding works, and what is the scenario of auto forwarding. So in service bus you have the auto scaling options, wherein at the moment uh, you have option to create up to 2000 subscription within the topic, right? But you cannot create more than 2000 subscription. But let's say if you have a requirement to create more than 2000 subscription, so what you can do here is you can use the forwarding options to subscribe from one queue to other queue. So your queue one has got 2000 subscription, and now if you got one few more conditions apart from the 2000 subscription, so what you can do is, so any messages which are not from these 2000 subscription or apart from these 2000 subscriptions, so what we are doing is you are forwarding that particular message from one queue number 1 to queue number 2, and then queue number 2 you've got another range of 2000 subscription which you can use it for the processing. So this is the way it works. So the sender sends a message to the queue number 1 which is on the green queue, and then immediately the message will be forwarded to the queue number 2 which will be received at the receiver end from those subscriptions. Yeah, so this is the auto forwarding code samples where you are saying that okay, you are defining two different queues. So before you define the source queue, first what we are doing here is we are defining the destination queue, and within the destination queue, once you define the destination queue, you define the source queue, and you will say okay, this is my source queue, and the queue definition or the queue description says a message is going to be forwarded to the destination queue in this session. Okay, like this. This is the code sample. Now sixth one is we are going to discuss about the first in first out with the sessions. As per the definition of Microsoft Azure Service Bus queues, Service bus queues and topics are basically first in first out by default, but the order of the messages or the processing of the messages, basically order of the messages will be in the first in first out, but the processing of the messages is not guaranteed to be in the first in first out. Let's say if you have a queue which is collecting the messages from the sender, it has got the messages in a particular sequence, all the messages are in sequence, but if you have got multiple receivers, so it might possible that based on the different frequencies, all the receivers are receiving the messages, and it might possible to your message one which has been sent at the very first in the queue is being processed late, whereas the message 2 which was back to the message 1, it was processed bit slow. Okay, so in this case how do you maintain the order of the messages? Basically in that case you can use the session. So what session will do here is, let's say you have got multiple messages, so you can define the session ID for your sequence of messages. So let's say you have got couple of message or the collection of messages which is which are the related message for a particular receiver to be processed on. So we can decorate those collection of message with the session ID, and once and after that we will have multiple sessions with multiple messages. So let's like in this particular demonstration you can see that in the slide you can see that I have got two sessions, session S1 and S2. Session S1 has got three messages which is green color, and session S2 has got uh, message with the magenta color. Okay, so what will happen now at the receiver end, and how receiver will act on this is basically when you define your or declare your service bus queue descriptions to be session enabled, basically it creates virtual queues within the queue. Okay, and you have got queues within the queues or the virtual queues which is designed as for the different sessions. So let's say you've got the session 1 which has all the messages which are declared with session 1, and you've got the session 2 queue which has got all the messages related to the sequence, which has got all the message related to sequence or the session 2. Now what will happen is all the message which the receiver 1 is waiting for messages received at the session 1, so it will receive all those messages, and receiver 2, which is waiting for all the messages with for session 2, then it will act on all the messages on that. So in this case, it is recommended that you design your applications in a way that uh, you create a long running session so that your session is not expired very soon, and your receiver who is receiving the message, it is keep on getting the messages on the same receiver location, and it will act on it without losing the context of the message basically, or the sequence of the different messages. If you look at the sample code here, what we are doing here is we are specifying the session id for at the time of creating the message for. So in this case we have declared two different session id with the help of random number, and when you send the message at the receiver end, we are saying that they declaring the receiver sessions. We are saying client dot register session handler. So at the queue client registering the basically handler at the receiver end, we are, instead of registering the message handler, we are registering the session handler. Okay, this is what the difference is. Next is the scheduling of the message. So service bus has a feature wherein you have the option to schedule the message for on a specific time duration. So for example, sender has sent the message to the service bus queue, but it might possible that you want your message to be processed on the specific timeline. For example, you have the high volume transaction going on at the office hours, business hours, and on that high volume transaction time, you don't want your background processing to be happen or the reporting data to be generated at the same time, because if that is going to be happen, your database transaction might delay, and your reporting data may put some extra overload on the database. So what possibly we can do here is we might say, okay, even though I'm receiving the message, let's let them receive it, but the processing of the message I want to process after the business hour. Let's say at the night time between 9 p.m. to 4 o'clock in the morning. So in the night time, I want to process the message so that the in general public is not using the your application, and when it is not being used, I'm performing all the background processing on those messages to prepare the background reporting jobs, or calculating some of the database calculations, or any other workload which I'm performing with the help of those queued messages. So in that case, in those scenarios, you can use the scheduling of the messages. So this is how you can schedule the message. So when you're creating the brokered message object, you can define the schedule in queue time, and also at the sending time, you can, instead of sending the message send message method, you can use the schedule message async method. Okay, now let's look at the duplicate detection, how it helps to you know improve the transaction, or to improve the capabilities of the service bus queues. So duplicate detection basically prevents duplication of the messages. So in case, let's say, if your sender is sending the same message twice or multiple time, more than two times, with the same message id, or the same message id and same definition of the message, in that case, it is going to be the duplication of transaction, or you might get a faulty transaction. In such cases, to avoid that scenario, what you can do is you can leverage the service Azure Service Bus feature, which is called the duplicate detection. So basically, duplicate detection prevents the duplication of message, and the duplication of messages are basically identified by the message id. So whenever you are sending the message, and if you are really concerned about duplicate message, so you need to make sure that your message ids are are unique for that particular message. So let's say if you are uh, sending the same message again and again, then you need to make sure for that specified duplicate detection timeline, your message ID is basically unique across. So what will happen in this case is sender will send the message, and in that case, if let's say sender has sent the same message again with the same message ID M1, so what will happen, the service bus will basically will drop uh, the previous message, and it will maintain the single copy of the message in the service bus queue, and then receiver will receive that particular message. So we have discussed some of the important feature of the service bus, and just to add on to that, there are so much to be covered in the service bus. For example, we have discussed the auto forwarding, we have discussed session messaging, dead letters, schedule delivery, message deferral, batching. I can show you the demonstration of the batching as well in the quick session. Yes, you can apply the transactions as well in the service messages, so that once you decorate your application messages within the service queue with the help of transaction, what will happen is you will basically uh, asking your service bus to perform either everything or nothing kind of things, atomic consistency behavior for your application messages within the service queue. We have discussed about the filtering actions, auto delete on ideal. This is again one of the properties which you can specify in your service bus description. So if your message is ideal for let's say 5 minutes of time and it has not been received at the receiver, for example, let's say I'm working on a chatbot application or the chat application wherein I'm broadcasting the messages to the different subscriber, and if the subscriber is not able to receive that particular 5 minute of duration, for example, then I might want to delete that particular message instead of distributing for wide range of timeline. Again, we have discussed the duplication as well. So this is all about the service bus queue and the service bus topics and subscriptions. Let me go ahead and show you some of the different behaviors or the different configuration which you can define in the service bus. So if I go and check the topics, so here in this case I have topics again with this sender and receiver. So in the sender and receiver, so what we are doing is we are saying, okay, this is my sender. So I'll just quickly walk through about this topic subscription. Save it first of all, save all. So we are sending the messages here to the service bus queue, and instead of creating the queue client, we are in this case we are creating the topic client, and we are saying okay, this is the name of my service bus queue, and this is the name of the topic. Again, at the receiver location, we are creating the service bus subscription client. Instead of the topic client, we are creating the service bus subscription client, because the message will be sent to topic, and then topic will distribute the message to the different subscriber available within the topic. We have seen that when we define our service bus queue, within the queue, within the topic, we have defined different subscribers. So if I go back to the queue again, my service bus again, I have this pizza order topic, and within the pizza order topic we have the multiple subscribers, right? So any message which is coming here is basically subscribe to that particular message, to all the messages. So yeah, so last but not the least, let me show you about the security within the service bus. So you might see in our demonstration, you might have seen that we have used the same shared access signature at the subscriber and as well as the sender end. So let's say my application is the sender of the message which is publishing the events to or broadcasting the messages onto the service bus queue, and we have the topic and different multiple n number of subscribers which are at and and we have got those number of receiver which are subscribing to those messages. So how do you maintain the security of your service bus? Obviously, you should not use, or you must not use basically the service bus connection string which we have used in the demonstration. Yes, you can use that. Once you use the service bus keys or connection string for accessing any queues or topic available in your service bus, you will get the full access. But by that means that you would, or somebody using these queues might be deleting or performing some anonymous access kind of thing. For example, I have got 10 queues, and two of the queues are related to some different subscribers. Couple of the other queues are for some other receivers. I don't want to give cross access reference to the subscriber or receiver A to receiver B. So in such cases, to maintain the integrity or to maintain the security or the trust of the service bus, what we should do, instead of using these queues, we should be using the individual queues or the topics shared axis. So when you define the shared axis, you can go ahead and create a shared axis. Let's say I'll call it for receiver 1, and I can say receiver 1 is only allowed to send the message. Yep, something like that. And then I can say create another one, receive sender. Sender 1 is basically only allowed to send, for example, and receiver is basically only allowed to listen them. Okay, so something like that. I'm going to manage the permissions here. I With the help of this, you can manage the permissions and of your queues and the topics. So by doing that, you, even though they have the access of the queue, but the sender will only be able to send the message, receiver will only able to receive the message. They won't be able to perform any other activities apart from that, right? So similar thing you can do for the topics as well. For each of the topics, what you can do is you can define the access type, and here on the access policies level, and you can say, okay, these are the things. Okay, I hope this was real helpful. Thanks for watching it. If you like the video, please give it a thumbs up and subscribe to the channel. Thanks for watching it. See you.